हे गाइस, उम्मीद करता हूँ आप सभी लोग अच्छे होंगे। तो आज की हम वीडियो में कल क्या रहे हैं, लेट मी क्लैरिफाई। आज की वीडियो में हम एक्चुअल पाइथागोरस के प्रूफ करने वाले हैं। ये नई सीरीज है, इसमें मैं हर चीज़ का, जितने भी चीज़ों का मुझे प्रूफ आता है ऑफ ज्योमेट्रिकल थिंग्स, मैं उन सब का प्रूफ करने की कोशिश करूँगा। तो आज हम शुरू करने वाले हैं पाइथागोरस थ्योरम से। तो ये वेल नोन थ्योरम है, आप सबको पता होगा। और ये थ्योरम स्टेट्स क्या करते हैं, लेट मी से दैट if there consists of a triangle which is a right angle triangle and the 90 degrees lies between the sides A and B, so this simply implies that A square plus B square is gonna be equal to C square, which is the hypotenuse. तो चलिए इसका हम प्रूव करते हैं. So we are gonna prove this theorem by two famous methods. One is by the area method and the other one is by the rotation method. And if I tell you my personal opinion, I like the rotation method way better cause इसकी applications हमें बहुत जगह पे देखने को मिल जाती है और इसके ideas बहुत से problems में use होते हैं. तो my favorite one is rotation. तो चलिए proof करते हैं. इसके multiple proof हैं but ये दो मुझे अच्छे लगते हैं, that's why I am going to prove this by these two. So for the first proof number one, let me write it down. We will create a triangle. Let me do it again. Let's create this right angle and let's name this A, B and C side, and we will create a same right angle but the sides will be flipped. So like this side will be B and this will be A and hypotenuse will be remains the same. And let's connect these 2 points. So it's a trapezium. If you could see that this and these sides are parallel. So let's write the area of this trapezium. Let's do it by the help of triangle. We see, let's write the area of this triangle. So we know area of a triangle is half into base into height plus, let's write down the area of this triangle. It will also be half into base into height, and let's write down the area of this big triangle. So we know that this is 90 degrees, so it will also be equal to c square by 2. And if you know that the area of a trapezium is nothing else but then the sum of parallel sides of trapezium and the sum of opposite sides divided by 2. So let's write it down. The sum of opposite sides is a plus b and sum of parallel sides will be a plus b also, and let's divide it by 2. So this both things will be same, so let's just do simple simplifications. This will be 2 and this will be the 2ab plus c square, and oh, what happened, okay, and it will be a plus b into a plus b by 2. Let's just cancel these things out and it will be 2ab plus c square equal a square plus b square plus 2ab. Oh, what? Oh, equal to 2ab. Let's cancel the 2ab out, so it will just simply be the result we wanted, a square plus b square equals c square. So let's make a box around it. This will be our proof, and our first proof is done. Let's move on to the other proof number 1. And let's go to the other proof. Let me change the whole page. this will be our proof number 2, which is my favorite proof, and which is a proof done by the help of the concept of rotation. So let me tell you a little thing about this proof, why this proof is let me make it again. Okay, so proof number 2 is by the help of rotation. First of all, let's create a triangle, right angle triangle. Here is a right angle triangle. Let's name the sides. Let this side will be C, this will be A, this will be B. So what we are gonna do is we are going to create 3 squares corresponding to the sides of the triangle. Okay, let me just show you how. Let me change the pen color and let's create this square which also has the side length of C. Let me create the other square corresponding to the side length of A, and similarly goes with the other square with the side length of B. So we have created the 3 squares, and let's just name them out. Okay, so I'm gonna name them like D, E, I, then it will be G, then this will be J, then this will be K. So we have named them, and let us first of all join these sides. Okay, and let me also name the triangle. It will be a little helpful. This will be A, C, B. So what we are gonna do? So we are going to first of all join the sides AI, BJ, and CE. Now we have joined these 3 sides. Okay, and let's join CD also. Let's just not join CE for now. Let's first of all join CD for now. Not CE but CD for now. So what we could see that if we just rotate the triangle, we could clearly see the triangle ADC. If we just rotate this triangle by 90 degrees with the counterclockwise direction, we would get the same result as this, which I'm going to write, that the side AD will become AB, the side AC will become AJ, and the most important one is side CD will become BJ, and all of these sides will be equal to one another, like CD will equal to BJ. Let me create a box around it because it's important. So now we have come to this. Now what we are gonna do, if we just intuitively just see this figure, we could clearly see that this will be perpendicular to this. Let me also give you a reason why. When we rotate something, it's rotate in a concyclic manner, right? Everything's rotate, and when we have rotated this 90 degrees, this simply means that the CD will be perpendicular to BJ. So what we are gonna do is we are going to write this down. So CD is perpendicular to BJ. So we know that. So now what we are gonna do, we are going to draw a perpendicular from C to the DE side of the square. Let me just draw it down for you. Okay. actually there is gonna be a mismatch in the figure, sorry for that. So we have drawn a perpendicular from C to DE. Let's name some points. Let's name this point as H and this point as X. So we have named these points. So what we do next? Give me a little bit of time. I'm also thinking right now. So let me think. So let me tell you what I'm thinking. I'm thinking that, just let me give you the taste of this wonderful thing. What I'm just thinking right now is to equate the area of D square J A C J K to be equal to A H X D, and area of H X E B to be equal to the area of C G I B. This is what I'm thinking of right now. So if I just able to equate the areas of this and then add these things up, this is, what is this? ACJK is just B square, and what is CGIB is just A square, and what is these two added sum is nothing else than the C square. If I'm able to do this, I will be able to do B square plus C square. Oh sorry, my bad, it's not B square plus C square, it's B square plus A square equals C square. So I will be able to come to this conclusion. So for that, let me just erase this thing. So for that, what I'm gonna do, let me create a boundary first. I'm thinking of doing the whole solution on a same page. So okay, this will be fine. So to do that, let me just see. We are able to see the triangle AJB, and we know that triangle AJB is area of triangle AJB will be half into perpendicular into base, and we could see that its base is B and its perpendicular is also B, so it will be half B square. Similarly, if we do this for the triangle ADC, it will also be half of B square. And if we could see, we know that we could say that ADC is equal to AJB, and we also know that ADC, area of triangle ADC, is nothing else than the half of the square of AHXD. Oh, sorry for that. AHXD. If you just clearly see that, you could just simply prove it by similarity and a little angle basin. So we know that this. So what we are gonna do is, we are going to prove this ADC is equal to ABJ. Oh sorry, my bad, what I'm writing. Oh, pardon me for oh please, I don't know. So where will we? Okay. We have no till this. So if we just add the triangle ADC and ABC, we will get nothing else but the area of the triangle, area of the square AHXB, which is nothing else than B square. We have come to this conclusion. And if we do the same for, let me write it down. If we do the same for the square HBEH, we would be able to find the area of A square. You could just do the same by the help of creating the triangle ABINCEB triangle and rotating it again and just making the things parallel and doing the same, you will come to the same conclusion. And if we add both things up, what we are going to get? A square plus B square equals C square, and here C square signifies the area of the square ABED, which is nothing else than the area of AHSB plus the area of HBEX. You could just simply see this. Let me just make a simple area of this square plus this square equal area of this big square. I think you hopefully understand the solution. Let me just broaden it. So this was the two solutions of the Pythagoras theorem. I think you like this solution. If you want another sessions of this, please like this video, or you could leave a comment, or you could tell me or you could leave a feedback. You could tell me what things I could improve in my proof telling or in my solutions videos. So that's it for today. I hope you liked it. Bye.